let's take up a few sums over here. Now before, there is also something else I would like to add once we finish this particular example, just to remind you. Now here, for example, we have a question here. If the roots of the equation 2x square plus 8x minus m cube are equal, the value of m is 0. Now remember, whenever you have any question concerned with nature of roots, we have to quickly calculate b square minus 4ac. There are two types of questions. One questions will be based on finding the nature of roots. The other type is the nature of the roots have been given as data and some other unknown has to be found out. Now here we need to find out b square minus 4ac. So we need to compare this. Remember one thing, in comparison, see to it that the x square term comes first, then the x term, and then the constant. And one more very important thing which would make it easy is convert this whole thing. See that the coefficient of x square is positive. For example, the same question, if it had been given as minus 2x square minus 8x plus m cube is 0, it would be very advisable to multiply throughout by minus 1 so that we get this, and so that the value of a becomes positive. Then calculations become easier. Now if you see, a is equal to 2, b is 8 and c is minus m cube. Therefore the discriminant, that is b square minus 4ac, would be 8 square minus 4 into 2 into m cube, minus m cube, I'm sorry, into minus m cube. Now this will become 64 plus 8 m cube, minus 4 into 2 minus 8 into minus m. Now it is given that the roots are equal. If we revive, the roots will be equal when b square minus 4ac is 0. So we have to equate 64 plus 8m cube equal to 0. So 8m cube is equal to minus 64. So m cube is minus 8. Remember, cube of a number can be negative. Square of a number cannot be negative. If you multiply minus 2 by itself 3 times, we get thing. That means m is equal to cube root of minus 8, which is minus 2. So our answer, the option over here, is going to be minus 2. So what we have done is that we have found out a, b and c, found out the value of b square minus 4ac. Since it has been stated that the roots are equal, we have to equate it with 0 and you get 64 plus 8m cube. Hence, if the roots of the equation 2x square plus 8x minus m cube is equal to 0 are equal, this is a given information, then it follows that the value of m is minus 2. And yes, we do have it like this. Now there is one very important thing that is to be understood. Now generally, suppose you have the root of, there are two roots of a quadratic equation. We're not talking about this particular equation. Suppose there is a particular equation and you're getting the roots as irrational numbers. So if one of the roots happens to be 3 plus root 2, we call it, say, alpha. It goes without saying that beta is going to be 3 minus root 2. This is true for any type of roots, but in case of an irrational root, it becomes very visible, because if you remember, x is equal to minus b plus or minus root b square minus 4ac upon 2a. So that means x is either minus b plus root b square minus 4ac upon 2a, or x is equal to minus b minus root b square minus 4ac by 2a. So individually minus b, 2a and root b square minus 4ac remain the same in both the roots, alpha and beta. The difference arises because of the plus or minus. This will be true for all types of roots, but in case of an irrational root, it's very, very clear. So remember, if alpha is equal to a plus root b, beta is bound to be a minus root b. In other words, we say that these roots are quadratic conjugates of each other. The rational part is the same, the rational part is the same, and the irrational part is also the same, but the sign before the irrational part will become the opposite. Then we say alpha and beta are conjugates of each other. So for any quadratic equation, the roots are bound to be conjugates of each other. we shall keep reviving this process off and on whenever we come across these kind of examples and even otherwise, right? So from here we move on to the next one, and we have here now it says the roots of the equation x squared plus 2p minus 1 into x plus p square is equal to 0 are real if what if this is true. Now these kind of sums, it's better to solve them because individually substituting makes no sense, for one thing because these are all inequations. So it will be better to solve them. So if you compare this with ax square plus bx plus c, what would be a? Right, a would be 1, b would be 2p minus 1, and c would be p square. Now here is just the opposite of the previous one. So it's told the roots have to be real. Now if the roots have to be real, it means that b square minus 4ac has to be either positive or it has to be equal to 0. So that means b square minus 4ac has to be greater than or equal to 0, because if it is less than 0, the roots would not be real, they will be imaginary or complex. So let us substitute this over here. B square, that is 2p minus 1 the whole square, minus 4ac minus 4 into 1 into p square has to be greater than or equal to 0. Now if you open the bracket, you get 4p square minus 2 into 2p. That is 2 into 2p into 1, that will be minus 4p, and this will become minus 4p square again is greater than or equal to 0. So here and here there is of course 1 plus 1, which I just missed, sorry. So you're using a minus b the whole square, which is a square 2p the whole square minus 2ab minus 2 into 2p into 1, that's that, plus b square, that is 1 square, which is 1, and this of course is minus 4p square. So this gets cancelled. So you're getting minus 4p plus 1 is greater than or equal to 0. So we can take an inequation has to be solved just like an equation. You can take it to this side. So you get minus 4p is greater than minus 1. Now here comes the catch. The moment you have an inequation, you're going to divide it by a negative number. So you have to take this minus 4 to this side, which is the same as dividing by a negative number. So this becomes minus 1 upon minus 4. But watch out here. The moment you divide by a negative number, the inequation would get interchanged. So you should get p less than or equal to minus 1 by 4. In other words, p should be less than or equal to plus 1 by 4. So the answer would be p less than. So basically you're solving an inequation as per the indication given over here that the roots are real. That means the discriminant, that is b square minus 4ac, has to be a non-negative number, that is it's either positive or equal to 0. Solve the equation, ultimately becomes a simple inequation, minus 4p plus 1 greater than or equal to 0, transpose it and we get this. The other option that we have here is keep the 1 over here, take the minus 4p to that side and you get 4p. Now you divide by a positive number, the inequation will not change. And even here you're getting 1 by 4 is greater than or equal to p, which is the same as p less than or equal to 1 by 4, either ways. So among these, our option is going to be p less than or equal to 1 by 4. So yes, we do have it that way. So just a couple of examples will slowly clear the cobwebs to understand how we can calculate b square minus 4ac and apply it in the given situation, right? Next, we have here is a very interesting example. We have here that if L plus M plus N equal to 0 and L, M, N are rational, that means they are numbers like 2 by 3, 3 by 5, 4 by 5, 2, minus 2, all those are rational numbers. The roots of the equation M plus N minus L, x square, plus n plus L minus mx plus L plus m minus n is equal to 0 are what? So what we can do in such case, there is one way is a very logical way of doing it is, the other way is a stronger logic, which says that if this is true for any rational number, put in any arbitrary values for L, M and N which satisfy this condition. You could take L as say 2 minus 1 and minus 1, so that L plus M plus N is 0. Or you could take it as 1, 1 minus 2. You could take it as minus 13, 6 and 7, 2. But those numbers are becoming big. So pick up the smallest possible numbers. Maybe you could take L as M, L as 2, M as minus 1 and N as minus 1, or this ways. Now if you're taking this way, okay. Now for any rational number, if this is true, then it has to be true for all rational numbers. So what we will do is, if L is 1, M is also 1, N is also, and N is minus 2. But you have chosen it in such a way that L plus M plus N is 0. You can't just put in any arbitrary value. You've taken arbitrary values which satisfies this given condition. Now what will hence this equation be? This particular equation's nature. So we need to find A. So M plus N, that is 1 minus 2 minus L, that is minus 1. The first one becomes into x squared, plus N plus L minus M, that is minus 2 plus 1 and minus 2 plus 1, and you have minus N, which is minus 1. So into x, right? And plus L plus M minus N. L plus M minus N means 1 plus 1. Minus N means minus of minus 2 plus 2 is equal to 0. So this will give you minus 2x square and minus 2x plus 4 is 0. So to make it simple, we can cancel away minus 2. So we get x squared plus x minus 2 is 0. So if you choose these arbitrary values, you are getting like this, which means that A is 1, B is 1, C is minus 2. Now we have to find the nature of the roots. How do you find the nature of roots? Find out B square minus 4AC. B square minus 4AC would be 1 square minus 4A, that is 1 into C minus 2, which would be 1 plus 8, which is 9. So B square minus 4AC is 9, which is a positive number. But remember, we have to check. So the moment you get positive, is it a perfect square or a not a perfect square? So it is a positive number and a perfect square. So the roots are definitely unequal, but they'll be real, unequal and rational. So the roots have to be rational numbers, real and rational numbers. So among these values, the one which would satisfy would be real and rational. Suppose you have taken it as 2 minus 1 minus 1. Obviously, B square minus 4AC would not be 9. But it will also be a perfect square, something like 16 or 25. So whichever arbitrary values you choose, which would satisfy this equation, if you calculate B square minus 4AC, the actual value would be different depending upon what you have chosen, but the nature is going to remain the same. That means you are bound to get perfect squares. So this is how we can solve these kind of an equations. So the answer is going to be real and rational. This is the fastest way of going about doing this kind of situations. So, and yes, we are right, the roots are real and rational. Okay, where do we go from here? The next that we have here is this. Find the positive value of k for which the equations x squared plus kx plus 64 is 0 and x square minus 8x plus k is 0 will have equal roots. That means you have to find the common value of k for which the roots will be equal. Now, if the roots will be equal, then b square minus 4ac has to be equal to 0. Now, if you look at the first equation, a is 1, b is k, and c is 64. So, for equation 1, b square minus 4ac is going to be b square, that is k square, minus 4ac, minus 4 into 1 into 64, that is minus 4 into 64. And this has to be equal to 0. because it's been given that the roots are equal, so that's the same as telling k square minus 256 is 0. K square is 256. Therefore, k is going to be actually plus or minus 16, but among these 16 is valid, so you take it only positive value, so consider only the positive value. So k is 16. But we need to check up this too. So it's for the second equation, b square minus 4ac would be minus 8 square minus 4 into 1 into k minus 4k, and this would be equal to 0. So 64 minus 4k is 0. So that means k is going to be, if you transpose it, you get 64 is equal to 4k. Therefore, k is going to be 64 upon 4, which is 16. So whether you're considering the first equation or the second equation, both ways you're getting the value of k as 16. Actually, here you will get plus or minus, and here you're getting 16. So both the equations simultaneously have only one value which satisfies both these conditions, and that is 16. So 16 is a common value which satisfies the given condition for both the equations. So among these, it is 16 is the right value, and hence we have it that way. Okay, now, and then we have that as 16.